Welcome to ACT Prep Day 29. You should take about 5 to 10 minutes. I want you to pause this video, work on your bell ringer. You can either work on it on a sheet of paper if you have it, or you may use the screen and do it on a notebook to turn in. So again, pause the video for about 5 to 10 minutes and then come back and we will check your answers. Okay, let's check these answers here. We are not solving these equations. We are just solving for A. And so what that means is you need to get A by itself. We're just rearranging this equation, much like when you have, this is a linear equation, 3x plus y equals 6. And you get it as y equals negative 3x plus 6. You've been doing this for a long time now with linear equations. This is solving for y. You're doing that exact same thing. You're isolating the a and getting everything else. B would be our independent variable, and a would be dependent on whatever b is. Now down here, I always tell my students that these are kind of hard because we don't talk like this in everyday language. Nobody says, go buy me 20 less than 3 times 4 donuts. Yeah, nobody. We give actual numbers. But sometimes you have to do this to solve equations and figure out what the number is. The one that's tricky is this last one. And I tend to do direct translation. And I'm going to show you what I do. So it's G divided by H is the same as, that always means equals, 7 more, I know that's going to be plus 7, I've done that, than 2 times the sum of G and H. Now, when I look at this section here, I'm going, that whole thing looks weird. 2 times plus GH. That lets me know I've got the distributive property. Anytime I see that, that's why I like doing direct translation, and I recognize that this plus needs to go here, and then I need parentheses to separate, because that's probably when it's the hardest. Okay, let's get into today's lesson, which is logs. Logs are pretty easy to do. Most students have trouble with it because they have not memorized the steps. This is one where you have to know how to convert from a log to a normal number and from a normal number to a log. And once you do, you've got it mastered. So what is the purpose of logs anyway? Like, why did somebody come up with this? Why? Well, we do this when we have numbers raised to an x power, like this. If I gave you 3x equals 9, you're going to go, that's easy. It's 3 squared, so x is equal to 2. What if I gave you this one? 3x to the x power equals 8. You're going to go, have no idea how to do that. That's what logs were for. Logs were invented to solve this equation right here, because this one's easy to do, this one's hard, okay? So here is the way that we write logs. You always have the word log. There's going to be to a base, b, then a number y equal to x. Now, what does that mean? That is this formula here translated to log form. So you can see the b becomes the subscript, the y goes here, and the x goes here. You literally just rewrite it in this form. That's it. So here's my example. Log base 10, 1,000 equals what? So this would be, this becomes my b, 10 to the what power, because x is the exponent, equals 1,000. 10 to the what power equals 1,000. Now that one's pretty easy for us because that one's squared, or sorry, cubed. Oops, made a mistake. 10 times 10 times 10 is 1,000, so it's 10 cubed. And if you notice, calculators have log buttons to help with that. Now, you're not going to have to actually find the log of something because you don't have to have a calculator, but you are going to have to use property of logs. And these are some properties that you have to know. You can only take logs of numbers greater than 0, so we can't do negatives. Can't do log base b of 5, because again, if you're multiplying, if a number is being raised to an exponent, it's not going to come out negative. That's why. Sometimes we will have a log where it is, let's say this is 2x, like our example here. You can split that out to be log base b of the first number plus log base b of the second. Now, here's the example. We've got 2x. I'm not going to be able to find the log of 3 to x, but I can find log base 3 of 2. 3 to what power equals 2? Now, again, I can't do that myself, but my calculator can. Now, if we're dividing, we're going to subtract. So here we have log base 2 of x divided by 3. I can separate that into log base 2 of x minus log base 2 of 3. And with the calculator, I can find 2 to the what power equals 3, so I can find this second half. And if we have a base, like here, raised to a power, this exponent here can drop down, as you see, as a coefficient in the front. So if I have log base 5 of x squared, I can take this 2 and move it down to the front. So 2 times log base 5x. And you're probably still going, this doesn't make any sense. But when you get to algebra 2, you're going to be simplifying equations, and sometimes those logs will cancel each other out. You have one in the numerator, one in the denominator. When you have the same thing divided by itself, it equals 1. They cancel out, they're gone. Okay? You need to know these definitions and properties, okay? And big thing, we can only use them as long as the base is the same. If they have different bases, there's nothing I can do with them. Okay, here's your ACT example. So you're gonna need to know how to switch it back to a regular equation, undo the log, that's a little hint. So hit pause on your button, take a moment to solve this, and when you're done, get back and we'll check the answer. Okay, let's check this answer. So if you looked, you're going to remember that this is, if it's log 2, 16 equals x, then that means 2 to the x power equals 16. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. It's x to the 4th power. Okay. Now you could have keyed this into your calculator too, log 2, 16, it's going to give you 4. How do you do that in your calculator? That's a good YouTube video assignment there, yes. Okay, there are 4 questions. So I want you to pause the video, set yourself a timer. You can use this one, put it on your phone, set a timer for 4 minutes, work on the practice questions, and when you're done, hit unpause and we will check the answers. Okay, welcome back. Let's check our answers. So here we've got log to the base x minus 6 of x squared equals 2. Yeah, kind of crazy, isn't it? Well, I remember properties when I have this. Can't I move this to the front? Yeah, you're going to work it like that and go, ooh, that's kind of weird. But I can rework it like this. I know it's the base, x minus 6, base to this power squared will be equal to x squared. Hopefully some of you bells are going off going, multiplying binomials. This ends up being x squared minus 12x, because you FOIL, plus 36 equals x squared. Now I can subtract x squared from both sides. Ooh, let's subtract it, because this one's kind of hard, so I want to make sure. And now I get negative 12x plus 36 equals 0, because x squared minus x squared is 0. Now I'm going to move the 36 to the other side, and I get 12x equals negative 36. You can see how this is working out nicely. So x is going to be equal to 3. Now, if that didn't come to mind, could you always start plugging in values? Sure, but you've got to know if you do 3 minus 6, that's going to give you negative 3 squared should be equal to 3 squared. Now this next one, this is simply 3 cubed. If we rewrite it, it's 3 cubed equals x. Well, what is 3 cubed? 27. Here we've got, okay, 2 log 4 2x equals 4. Well, the first thing I can do is divide by 2 on both sides and get log 4 of 2x equals 2. So now you basically have 4 squared equals 2x. So 2x equals 16. What does that mean x equals? Hopefully you're screaming, that means it equals 8. And you were right, yes. Now, last one. Here we've got, what is the real value of x here? Now, the first thing I notice is same base, different base. So if I add these together, that would be the same as multiply. There's 2 different ways I can do this. I can go 4 times 2 is 8, so 2 to the what power equals 8. Or I can go 2 to the what power equals 4. So this is really 2 to the x power equals 4. So this is going to be equal to 2 plus 2 to the what power equals 2. So this one is going to equal 1 equals, okay, log 5x. I'm doing nothing with this side. Now, hopefully, bells are going off because now I've got log, I'm just going to rewrite it, 5x, because I can do that, is equal to 3. It's a 5. And so now it's just 5 cubed equals x. What's 5 cubed? 5 cubed, I'm undoing the log, equals x. 5 times 5 is 25, times 5 is 125. Yes. Hopefully everybody got them all right. Now, your exit ticket is very, very straightforward. They're giving you 6 cubed equals 216, and they want you to write it in log form. And if you're sitting here going, I don't know how to do that, go back in your notes. It pretty much told you on the first couple of slides how to take a regular exponential equation and turn it into log form. You just move the stuff around step by step. Again, if you need help, shoot out an email or ask in class, and I'll see you for day 30.